Hello, I welcome you all to this another interesting screencast. The problem reads determine the minimum coefficient of static friction mu s between the cable and the peg and the placement D of 3 kilonewtons force for the uniform 100 kg beam to maintain equilibrium. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we are being asked to determine the minimum coefficient mu s between the cable and the peg. So this is the peg and this is the cable. So we want the minimum coefficient between the point of contacts. So let's draw the free body diagram. We've been told that this beam weighs, it has a uniform mass of 100 kg, so it will be acting at the very center of gravity, which is the mid-span. Okay, so let's imagine we have this 100 kg here, converting it to weight, we multiply by the acceleration due to gravity. This gives us a 981 newtons. Okay, so let me convert this. Alright, I'll write it later on. So and then we have the dimensions. This mass is acting at 3 meters and then 3 meters, right? And if we are to do a section here, we'll do a section there. We expect some tension force there and like so. Okay, so let's call this tension force here TA. Okay, TA. Then this side we call it TC. Okay, great. So there we go. Once we've done this, then we can apply the equations of equilibrium for this bottom part here. This is the one that has, we are starting with this one here. Okay, right. So how many unknowns do we have? We have TA, we have TC, and we have D. Therefore, the equations of equilibrium are enough for us to find these. And once we found these, then we're going to use the friction equation and the model for a cable going over a curved surface. Okay, so let's take moments about point A. So say summation of moments about point A equal to 0 and clockwise being our reference. So we have TC, sine. So this will have some components. So there will be a component there, and then there will be another component there. Okay, this component is TC sine 60. Then this one is TC cos 60. This also will have components here, this one there and this one there. So this one is TA sine 60, then this one is TA cos 60. Alright, so let's continue. So TC sine 60 times the lever arm, which is 6, minus this one has consumed my space, that's 1 minute. So this one is going to be equal to TC sine 60. I just want to reserve my space. Okay, so TC sine 60 times 6, and this is anti-clockwise or positive moment, times 981 by 3, and then minus 3000. These 3 kilonewtons have converted to 3000 newtons times D. since my 981 is in newtons, equal to 0. Therefore, making TC subject to a formula, TC will be equal to 566.3806 plus 577.3503D. Okay. Then we have summation of forces in the x direction. Okay. What we have? We have TA. We have TA cos 45. TA cos 45 minus TB cos 60. Okay, equal to 0. Making TA subject to a formula, TA is going to be equal to TB. This is not TB, this is TC. Okay, this is TC divided by TC cos 60, okay, divided by cos 45. This therefore gives us a 0.7071 TC. Okay, then we have summation of forces in the y direction, like so. What do we have in the y? We have TA sine 45 plus TC sine 16 minus 3000 minus 981 equal to 0. So replacing this TA here, we use blue. Replacing this TA here, we replace TA here. TA there, and then make TC subject to a formula. We'll find that our TC is going to be equal to, our TC will be equal to 2914.3045 newtons. Okay, and then we know that so this is our TC here. Alright, so replacing this TC here, okay, here, okay, we'll find that our TA will be therefore equal to 2060.7047 newtons. Okay, so there we are. So now we want to find the minimum coefficient of static friction between the cable and the peg. So we have TA, we have TC, and since our TC is greater than TA, we expect TC to be equal to T2 and TA to be equal to T1 for us to have the minimum coefficient of friction. So we have the equation T2, T1, E, which is a constant, a base that is used in natural log, to the power mu times beta. Alright, so beta is equal to, these angles here, right? This angle here is 45 and the other angle there is 60. So we are adding the two angles. So this gives us a 45 plus 60, which is equal to 105 degrees. This is the angle over which the cable is in contact with the peg. Converting this to radians, beta will be equal to 2 pi times 105 degrees divided by 360. This gives us, if you are to get it as a decimal number, 0.5833. I want this number of decimal places to maintain accuracy. Pi. But if you do not want to work it like this, you can use it as it is as a fraction. Right. So we have our beta. So what we need to do is to plug in all these values in our equation. So let's do so. So let me just create this boundary here, so that like so. So let's go ahead. We said our TC is our T2. So we have 2914.3045 equal to 2016.747 times e to the power mu times 0.5833 pi. Okay, leaning both sides and dividing, we are going to have lean of 2914.3045 divided by 2060.7047 equal to lean of E times mu times 0.5833 this. So making a mu subject to the formula, mu is going to be equal to 0.1891. Okay, we are not yet done. They also asked us to find D. Okay, so using this equation, TC is equal to 566.3806 plus 577.3503 D, making D subject to a formula. Since we have TC is equal to 2914, TC is here. Okay, so we are going to plug in our TC. We're going to plug in our TC there. Okay, and make D subject to the formula. And if we did so, our D is going to be equal to, I'll write it to 4 decimal places. D is therefore equal to 4.0667. Okay, which is just merely 4, right? Alright, so we have mu minimum. Finally, we have mu minimum, which is equal to 0.1891. And we have D, which is just equal to 4, right? Okay, I'll write the whole lot of it. 4.0667, but this is just 4 meters. Okay, I think this is about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, and continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.